Okay, so let's talk about polymorphism. If saying the word polymorphism makes your head hurt, don't worry, it's not that bad. Polymorphism means that they have many forms. Polymorphism is all about variation. Polymorphism is a fourth major concept of OOP, alongside the others we've learned: abstraction, encapsulation, and inheritance. So there's two kinds of polymorphism in OOP. Number one, methods can be polymorphic. Number two, classes can be polymorphic. So what is this exactly? Let's learn by example. So method polymorphism. Here, let's start it off. You have your class, simple class. You create your simple class. You have your public integer add two numbers. You're gonna have A and B. Inside your registers, here you're gonna have int results A plus B. That's what you're gonna tell it to do. Go ahead and print that out on the consoles. Return the results, and then public integer add three numbers. You're gonna have A, B, and C. Now you're just gonna add a C into this one. Still using A and B in the same registers. Int results. Go ahead and just put the third one in there. Print the results in. Return the results, and then here you're gonna have a string. Add words. A and B. Concatenate A plus B with the space. Return the results. And then write it out in the console line. Okay, so here we have a class with three different methods. It's pretty obvious what these do. Rather than have three different methods, we have one method with three different variations. To make this polymorphic, all we need to do is rename all the methods to the same name. So here's a new version that is polymorphic. There's one method named add with three versions: class simple class, static polymorphism, method overloading. So here you know that this here is just one. It's just gonna be just a definite with the method with the function that's just going over values. So here you have A and B. Go ahead and have an add function. A plus B, return the results. This is just the same thing up there. This one also goes by several other names, including static polymorphism or early binding or method overloading. They all mean the same things. We have many different versions of the add method to pick from. When we go to use the add method, we'll see are now told that there are several versions available. So here you have a simple class. My object equals create a new class, simple class, and then my object dot go ahead and do this function add and throw the object out. Versions or option 2 or 3 for this method. The second form of polymorphism we already seen in lesson 7. We create an abstract and virtual class in the parent, then change how they behave in the children. This is known as dynamics polymorphism or late binding. Again, they all mean the same thing. When we switch up on how method works in the child class by using abstract, virtual, and override. So class polymorphism. We have already seen this class polymorphism. Inheritance itself creates class polymorphism. In the previous lessons, we saw that the dancing cat is a cat and an animal. We can run a quick test to prove that the child class are just another version of their parent class. So here you have your class program: static void main, string square bracket arguments. Simple class, my object equals, go ahead and create a new one, new simple class. Go ahead and throw an add function with 1 and 4. This is going to return a 5. Same thing with 6, 9, 11. This is going to return a 26, and just do a string right here. A simple hello world. And then just have a child class. Child equals new child. Create a new child class, and go ahead and have an if condition. Child is. So here we're making an is equal to a simple class. Console write line that the child with some of these text or string in there. And go ahead and just go through the GitHub and look for project 9 code example. Key terms you guys want to remember is static polymorphism, early binding, method overloading, dynamic polymorphism, and late binding. Alright, let's talk about working with files. First, give yourself a huge round of applause. We all have covered all of the core concepts of OOP: classes, abstractions, encapsulation, inheritance, and polymorphism. None of this was easy. The awesome news is that you learned apply not only this to C# but so many other languages. So you could apply this to JavaScript, C, C++, other any other type of languages that do a lot of object-oriented programming. We really begun to get a good foundational understanding of how to be a good coder. For the rest of the course, we're going to begin looking at common tasks you might have in web development along with some general best practices. So in this lesson, we're going to show you how to work with reading and writing files to the computer. A common task in web development is writing to a log file or reading from a text config file. We're creating a feature that logs when a user logs into our website. This will be a simple example that would be more complex in the real world, but the goal is to show you how to work with files and what these features might look like in the real world in a very basic form. So number one, planning out your code. That's a very good example here. So these are very good content right here, right? So you want to plan out your code. First, we need to figure out what classes we'll need. For this example, we create two classes. Number one, a file writer class. This class will hold code that write log files. Number two, a user account class. This will hold the code that represents the user's account. So here we're going to just get into a little bit more like writing in notes, logs, and number two, creating the file writer class. In order to write to files, we're going to use C# built-in file class. To access it, we need to use system.io to the C# class. So here you're just going to have another thing in your tool belt using system.io and using system.text. Alright. Next, we need to define where we'll write our files. We declare a constant that points to where we want our file writer to write a new file at. So class file writer, private constant string user log file, and whatever your user log.text. All right. To test that our file writer is working, we create a test method called example write file that will write some text to a new file. File.append all text. Go remember that right there. File.append a text. Parentheses is a built-in C# class that will write out our data to a file. We can test that our file writer class is working by creating a new file writer and running the test method. Alright, so here you have your public void example write file. First function. Here you're going to have a little bit more input. Go ahead and put your string file name is equal to this right here. Whatever your this is located, and then whatever you want to name your log text, your string data, whatever you want to have this printed into your log. So print this info to the log, and then go ahead and put a /n, which that means indicating that you enter down another new line. File.append all text, file name, and data. So here you're going to have file name and data. Okay, so file writer equals new file writer. Go ahead and create a new file writer example write file. So here on the output, you're just gonna have all this contained into your notepad when you do execute your program. So next we need to create a method that write a user login entry. Get some coffee real quick. Public void update user log, string username, date time, login time, bool. Okay, so we know that this right here, we're gonna create a username. It has to be in string. We're gonna make a login time. We're gonna give it a date time, which is automatically sets, and we need to know if the login was successful by two logical operation, true or false. Let's go have a conditional statement, and if this doesn't work, then this must work, right? So file.append all text, user log file, and log entry. Else, this would be a bad password. If not, then it'll be successfully logged in, right? So we're gonna have two cases here. Number 3, creating the user account class. This class will represent the user account. class user account. Okay, so everything, right? If you're creating a username, password, all these sensitive type of data that you don't want the public to see, you set it to private, correct? So you're gonna have your username, password, last login date, and then your date time, which does the date time for you. Your integer, bad password attempts, and your bool is logged in, true or false. So how many times have you have a bad password attempt? And you're gonna create a new file writer. So you're gonna have username and password. Throw it out that you need to have a username and you need to have a password. Notice that the user account class includes a file writer. Next, let's write the method for the user login. So same way it could be true for password attempt. So you're gonna have a bigger input, a little bit more data in here. What's it here is a little bit more refactoring. So is login equals true, file writer equals new file writer. We're gonna have a file dot update user log, username, login time true. Else if all that's not, then is login is equal to false. Go ahead and increment this by 1. How many times you've had a bad attempt. Create a new file writer, put a date time, throw it out, and username, login time false. So here we are testing to see if the password entered by the user matches the password defined when the user account was created. If it matches, the login is valid. We then create a file writer to log the successful login. Else, if the password didn't match, we create the file writer and log the bad attempt. Finally, we create one more method just to get the basic details of the user account. Go ahead and make a new method. Put this all into your console. For the output, concatenate this with your program or your little small methods. Username, last login, bad word, password attempts. Is it logged in, right? Back into our main program. We create a simple test to verify everything is working. This code will create a new user and then perform 3 login attempts. The first 2 attempts will be logged in as bad. The third attempt will be successful. Okay, because he put the correct password, right? Okay, so let's look at this again. So here, user account, user, cool, user 1, secret password 12. So this is the correct password. Notice that here, what he put in. Forget password. What did they put in right here? Password. This is not, these two does not equivalent to this. So the third one here, secret password, and you're going to put user.get user info. So this is just telling the instructions just to go get ahead and get the user's info, right? When we run our code, we'll see everything is working. And we check the log file and we see that it has written the results to file. Okay, so here this is going to be inside your console. That's going to be outputted. Very simple. This is going to be your program. All right. So this is very good for working with files and working with what you guys have been working with, right? Database. And inside your log file, you're going to have every piece of data that's been tried and not. All right, let's talk about string builder. Okay, C# string builder is the built-in .NET class for convenient building a long string of text. Okay, so remember we're gonna start working with .NET and some of the frameworks. In prior lessons, we combined strings with a line that looks something like this. So here, string 1 is equal to my first piece of string. Go ahead and create a second string. String more text is equal to this right here. So you're gonna have these two added together, and then just go ahead and write this out in the console line. All right. So string builder gives us more convenient way to combine text together. So very simple, straightforward right there. Could be a powerful tool to use. With string builder paragraph equals new string builder. Throw an object of a new string builder, create a new one. This is going to be your paragraph, right? Paragraph.append string 1, append.string 2, and then go ahead and add this right here, adding yet more text. And then console write line, paragraph 2 string, and throw it out, okay? String builder gives us a helpful function called append that lets us just glue more text onto our string. To print the entire string, we can use the toString function. String builder becomes a helpful way for us to generate HTML code. Let's look at the sample code that writes HTML for us. All right, so back into what we learned about HTML. String builder, HTML text equals new string builder. String body open is equal to your body. Your string body close is equal to body with a slash. This means it's closing. Same thing with a paragraph. String p open, p string p close, close it with a slash. Paragraph is closed. Console write line, enter some text you want to put on your web page. So here you're able to enter some data, bring it over to your HTML. String dynamic HTML. So here, this is known that you could actually interpret while onside the console. Okay, so HTML text.append, body open. This is all related to what you did earlier. P open, dynamic HTML, p close, body close, HTML text. File writer.create. So you're going to create the HTML text. We create a string builder and some strings that hold our HTML tags. The string dynamic HTML captures anything the user types on the console. The string builder puts everything together in the HTML, and then our file writer and the previous lesson writes the HTML to file. The end results, number 1, the application asks for the users to write some text. So enter some text you want to put on your web page. Anything I type will be inserted into the HTML web page. Number 2, a web page is created with the content the user provided. So, all right, so here's just you're going to be your simple HTML file, your web page. So right here, anything that they typed into the console will be output into the to this web page, right? This is a very simple and crude example, but this is so much of what we've been learning has been leading up to. Instead of just writing plain HTML pages, we'll be using C# and SQL to create dynamic pages where the content of the page is generated by C#, SQL, and ASP.NET. Okay, so ASP.NET. 9.4 lab practice creating dynamic HTML. So for your lab, I want this due right on Monday. Make it documented well. Have that uploaded to Canvas and also your GitHub, right? So, but mostly important, I want you to have it on Canvas first so that I can grade it. And make sure you guys document very well. So creating dynamic HTML, this should be one of your favorite program. This is probably one of my favorite program, right? It's very straightforward of web app. In this lab, go ahead and use a string builder and file to generate the .html pages. You build up an HTML file using a string builder and then generate the HTML file. Your HTML page will be including your anchor, heading 1, heading element with the title, and then remember your UL, your unordered list items. The content of H1 text and unordered list will come from typing text in the C# console. When the console executes, you may, if you wish, add additional HTML elements to the output. So example of a C# execution. So here, you're just going to be adding text to the header, add text to the UL. And here's going to be a very simple yet pretty strong program, right? So inside the console, right? So something you write here could be outputted to a web page like here, right? So view the 9.4 HTML solution to see our code example on how we generate the HTML. If you complete this lab early, work through challenges, exercise on 8-bit challenges to improve your skills. So I primarily want you to work on this project on your own. Go ahead and try to mess with it, figure out some codes that might not work, and if you actually complete it, then good for you. If you're still struggling, go ahead and check out the solution. All right, that's it for not for lab. Um,